Let's take a look at an example of exponential growth and decay. So a population of bacteria doubles every hour. If the culture started with 10 bacteria, so the culture is just where these bacteria are living, find a function that models the growth of bacteria. So what's happening here is that with populations of things, they're going to grow exponentially. So here bacteria is going to grow exponentially. So the function that we're going to use in general is this exponential model of A of t is a sub 0 e to the kt. So this is our general function. Our goal now is to figure out what are all of these pieces of our function. So one thing that we know is that we start out with 10 bacteria. So what this means is that a sub 0 is equal to 10. So my function here, I can plug that in. That is 10 times e to the kt. Now, the goal with these is often going to be to find k. We often don't know what k is, so we're going to try to figure out what k is. So we are going to solve for k. So what we have to do is we have to know something about t and a of t. So what we know is that things double every hour. So what that means is then when t is equal to 1, what is the number of bacteria we have? Well, if we start out with 10, 1 hour later that doubled, so we have 20. So we're going to use this information and solve for k. So we plug this in, so 20 is equal to 10 times e to the k times 1. So we need to solve for k, so the first thing we need to do is we need to get the exponential by itself. So I divide both sides by 10. So I have 2 is equal to e to the k. Now, since our variable is in the exponent, we need to apply natural logs to both sides. So natural log of 2 is equal to natural log of e to the k. When you have this, you're allowed to bring down the k. So I have natural log of 2 is equal to k times natural log of e. Natural log of e, we said that is equal to 1. So that says that natural log of 2 is equal to k. So this is my k value. I've solved for this. So I'm going to plug this back into my function. So my general function is a of t is equal to 10 times e to the natural log of 2 times t. So this allows me to calculate the population of bacteria at any given time. Now this might look weird, but this actually will work perfect for us. So if you wanted to try plugging in some values, let's say for instance after 2 hours. We know what that should be, that if we start out with 10, then after 1 hour that becomes 20, that should double to 40. So what happens if we plug in 2 into this function? I have 10 times e to the natural log of 2 times 2. So if you plug this into your calculator, you should get the answer of 40. So indeed, you can check yourself that you get answers that make sense, and this would be our answer. This is the function that we use to model this growth of bacteria where t is our variable.